Hey folks, sorry about that. This is part 2 of day 1. You'll notice that in the last video I was going over the construction of ozone, as well as talking about the good and the bad of the ozone. I apologize about that. It did get halted a little fast there at the end. But I wanted to emphasize over on the very bottom of this slide here that ground level is harmful, atmospheric level is good for purposes of absorbing the UV waves, and some of the issues that people have found over the history of humans is our usage of something called the CFCs, or chlorofluorocarbons. You'll find this in your reading as well as on a worksheet. But the CFCs have the ability to destroy the ozone and changing the ozone into carbon dioxide. And we know carbon dioxide is a greenhouse gas. Back in the 1980s, a hole was discovered above Antarctica, and this hole has been a bit of an issue and concern. However, you'll note, and again, please pause the video now if you need students to get their notes in. Alright, so you've unpaused. You'll notice here underneath these pictures that if we compare a 1979 and a 2008, you'll notice the hole is much smaller, the hole being indicated by the dark blue here, compared to the 2008 where the hole is quite large, encompassing all of Antarctica. They have discovered, though, however, that courtesy of agreements regarding chemical usage in companies and countries, CFCs have pretty much been outlawed here in the United States as well as many of the other modernized nations, and that the hole, while getting to a very, very large point in 2008, has actually been reducing in size. Now, some of you may note that in 2002 the hole was quite small. That was also a very, very warm year, and you're going to notice on warm years the hole actually appears smaller. But they have discovered that the hole has begun shrinking, and this is a combination of both the CFCs being made illegal as well as the planet going through its global climate change of a warming trend. So, guest teacher, if you want, there's a great YouTube video here you can watch about the ozone hole, and it is explained really, really nicely. Now, on this slide, this is the last slide of this class, but under this slide, I want to make sure I talk about the different compositions of gases that are found in the atmosphere. The mixtures of gases do range in percentage. However, it should be noted that the majority of it that's entering in your lungs is both nitrogen and oxygen down here in the troposphere. Nitrogen we cannot use within our cells and so forth. However, it must be converted into nitrates, which is a solid form, and this needs to be done by nitrogen-fixing organisms. So what I would go and put into my notes here, I would definitely go and put in the word composition of our atmosphere, and I would highlight nitrogen, oxygen, argon, and trace gases. And you're going to notice in one of your worksheets, the trace gases is a very low percentage, on the order of 0.4%. So that adding up here should get you really close to 100%. But nitrogen is 78%, oxygen is 21%, argon a very, very small percentage, and the trace gases as mentioned a second ago. What does that look like as far as charts go? And again, please pause the video if students didn't get the notes. The chart looks like this. In a large pie graph, our major gases are identified as nitrogen at 78, oxygen at 20, roughly 21%, argon at 0.93, and your trace gases at 0.04. What trace gases are we referring to? Hydrogen, krypton, methane, helium, and neon. And you'll notice over here they've even gone and brought in one of the trace gases is carbon dioxide. So, don't be surprised if I present you with a chart that looks like this, asking for you to identify the major gases, that being that of nitrogen, oxygen, and argon and trace gases. I would even suggest putting this into my notes, keeping it very simple, identifying the nitrogen at a little bit more than 3/4 of the pie graph, oxygen at a little bit less than 1/4, and both the trace gases and argon being these little thin slivers. So I'd recommend putting this chart into my notes. Go ahead and pause the video so students can get that information. Alright, unpaused. Let's see what's left here. Ooh, nice little picture here. Not a requirement that you write this into your notes, but a nice way of showing how the gases are mixed. You've got nitrogen over here, and this is at sea level right here, 0 feet or 0 kilometers above the ground. We also have oxygen over here and a little bit of argon. And as you go further up into the atmosphere, you're going to notice it becomes very, very rich in O, just O, which is where we find our ozone layer as well. And then we travel further higher above the Earth's surface, and we find we get mostly just helium and hydrogen at the higher elevations. It's a pretty cool little graph. And that's the end of today's class. Thank you very much, you guys. Next up is tree period. Tree class. All right, so in this class, I'd like you to go and make sure you finish. Students, this will be the agenda. It'll be pretty consistent from day to day. You have your homework planners and assignment planners. I'd like you to fill that in. That's about 5 minutes so. An SSR for 10 minutes, which would be advantageous for students to fill in their reading logs and speed charts. Your daily assignment for today is nothing. We're going to try and finish the Jurassic Park movie. Normally there would be a worksheet, and we're going to kind of rotate from day on, movie, worksheet on. Normally we'd have a daily assignment, and then we'd go into the movie, or students would work on their homework and study time if it's more applicable. But we're going to try and finish Jurassic Park today. If we don't finish it today, that's not a problem. You can finish it the next day. And then finally after that, you're going to be heading into the island as well as Back to the Future. The list of movies have been left for the students. All right, thanks a lot. Have a good one.